if they were not to meet, they would continue on forever without meeting, and a nice way to do that is just to use the thickness of your ruler to create two parallel lines. Okay, so you've just seen me do it here. I've marked an arrow on both of them, and what that tells you is they do not meet. It would be totally wrong to put an arrow on both of these, because it would be trying to say that they're parallel when they're clearly not, because they have an intersection point. Okay, so lines that are parallel, remember I'll use a small letter to name them, L, M, N, O, P, Q. The lines P and Q never meet, and if they never meet, they're parallel. Okay, so this is this would be a theorem. You could say the condition is parallel lines never meet, and you could also say lines, distinct lines in particular, that never meet anywhere are parallel. Okay, so it doesn't matter which one comes first, they both imply, and it's two-way implication. Okay, in other words, the converse is true. Right, so we go on to angles. We're just going to remind ourselves of some basic geometry around angles. And so you're best to take your 30, 60, 90 set square for this. That's this one. Okay, and let's just use the insert of it to create an acute angle. So the most generic basic acute angle is this 30-degree angle. Okay, so we will. Now I don't like the way the book hasn't denoted the points with a dot, but we're going to denote. We're going to denote points with dots like this. Okay, A and B and 0. Okay, so the angle above is written as angle AOB. Okay, now I personally find this hard going. Like it can be hard to read, and you can just use the individual letter, such as angle O. Okay, when the assumption is you're taking the smaller of the two angles that creates. In other words, you're not going with a reflex angle, you're going with what we call the ordinary angle. But when you have, so I just want to draw this again, and when you have several, so when you have a ray coming out of a line segment, okay, like this, now we might have points A, B, C and D. And now if I talk about angle D, you won't know what I'm talking about. You say, oh, this one is it? Or could it be this one? Indeed, could it be the straight angle down here? So that's where the confusion arises, and that's where we have to speak about BDC, angle BDC. Okay? So when several angles are concurrent or they're adjacent to each other. So in the case of adjacent angles, angles that are beside each other, adjacent angles, the 3-letter naming is needed. We'll try to do our best when we're doing exams to avoid 3-letter reading when we're working, when I'm making videos for you, and hopefully when you're modeling it yourself, so long during exams. But we have to be able to understand what this is. So for example, when they say BDC, I could go along here and just say let's call that X. Okay, we drive on from there. We have a right angle. Now if you're not doing this yourself, then you're not giving yourself as much of a chance to learn, because this hands-on learning makes it far more likely that you'll remember it long term. Okay, so the name of this type of angle here is a right angle. So any angle of measure 90 degrees is a right angle, and if you take point and the plane, and if you break it up, and I could use a set square, of course, just like this, but I could also do something quite adventurous here and use geometry to make a right angle. So what I want to do is I want to define my two endpoints of a line segment. This is the midpoint, and I can go with arcs of any length, but I'm going to go with this double arc kind of this way. Okay, and this way. Bring that up there. And I know I can't go the other end of this, but it doesn't matter. This is a right angle here because I already have my midpoint. Okay, or look, of course you can create a right angle this way too. But what I'd like to say to you there is, if you are using your set square, just make sure that you actually show the context of, you know, take that little line segment that I made there and bring it down as well, and show the context of 4 of them. That's the important thing, because then we know 360 degrees is evenly broken into 4. So that's where the 90 degrees comes from. So 90 degrees is extremely important, as is a straight angle. Let me see, it's coming next probably. The straight angle. Now the killer about the word straight is the spelling. So can you spell the word straight? Can I spell the word straight? Let's give it a go. Anyway, so what I would say to you is, what I know about that word is, when I get out here to G, I know things can be tricky, and I know it's not spelled the same way as the beginning of de. So that's your straight angle, and a straight angle is 180 degrees. You might wonder why I put a point on it at all, but I would prefer if they'd put a point there. So, because angles should have a vertex, should have a corner, and that's my vertex, and this is 180 degrees. So what's the measure of a straight angle? It's 180 degrees. Not 180%, 180 degrees. Okay. We have an acute. Did we not have an acute angle back here? We didn't. So we have an acute angle which is less than 90 degrees. In terms of your construction, basically we always want to talk about this working line. So let me introduce you to your working line. When it comes to geometry, the working line is really important. It just gets things started for you. Okay, so if you want an acute angle, use either, you know, you can just use your 30, 60, 90 or your 45 to make an acute angle. Okay, so that's 60, that's 30, and we'll put a 45 here. All of them are acute. So we'll mark the angles A, B, and C. And angle A, B, and C are all acute angles. And because an acute angle is less than 90 degrees, bigger than 0 degrees. Okay? Another way to write that is that it's between 0 but not 0, because that's called a null angle, by the way. 0 is a null angle. So between 0 and 90 degrees, that's acute. Okay, let's do a working line and go to obtuse. No difference here in terms of the construction, only that we'll choose what we call the supplementary angles. So I'm going to do this and this and this, and we'll talk about A, B, C, D, E, and F. So angles D, E, and F are all examples of obtuse angles. And what makes an angle obtuse? An obtuse angle is an angle that's larger than 90 degrees, because if it was 90 degrees we'd call it a right angle. It's larger than 90 degrees. Let's use the letter D. Larger than 90 degrees, and it's less than a straight angle. So any angle that's larger than a right angle and less than a straight angle is an obtuse angle. Okay. move on to the reflex angle. So, and in order now, what we have is we have an acute, well, we have a null, an acute. So what I'm doing here is I'm revising what we've learned already, and this is very good practice for when you're learning, is to keep listing. It gives you confidence in what you've learned. So you should be doing the same. We know what a null angle is, we know what an acute angle is, we know what a right angle is, we know what an obtuse angle is, we know what a straight, watch the spelling, angle is, and now we know what comes after that is a reflex angle. Now the thing about a reflex angle is it has a bigger range than the rest of them so far, because it goes everywhere larger. So start with your working line. You can hardly do anything in geometry without your working line. Okay, and actually let's go to this end point here. So instead of continuing on, we're just going to come down here this way, and we will say that this is a reflex angle. And by the way, collectively all of these are called ordinary angles. So if I'm to do up a set of ordinary angles, the names of all the ordinary angles are the null, the acute, the right angle, the obtuse angle, and of course I missed obtuse, and the straight angle. Okay, but a reflex is not an ordinary angle, it's outside of the set of ordinary angles. A reflex angle. Okay, reflex angle. Yeah, it says it there. I'm delighted they do that. Okay, it tells you that an ordinary, the shaded angle, which is less than, is generally referred to as an ordinary angle. So angles are either reflex angles or ordinary angles. Now angles can be larger than 360 degrees, but in geometry, you can turn around more than once. So you can have angles that are larger, and then a thing called clock mathematics starts. Clock maths begins, whereby if I said to you 400 degrees, then you'd say, but that's the same as 40 degrees. Okay, because you reset the clock, just like you reset the clock every 24 hours, you reset angle every 360 degrees, so you just take the remainder after dividing in 360. So that's probably everything we need to know, except we want to do vertical angles and angles at a point next. Okay, so vertical angles are very, very easy to construct. Just go back to where you take your where two lines meet. They meet at the vertex. Okay, maybe V for vertex, and then we can say what vertical angles are the angle opposite vertically, and we look at the words vertically opposite. So you want to write this down. So they're vertically, and it's got nothing to do with vertical up down. It's got to do with the vertex, and the adjective that goes with vertex is vertically opposite. So vertically opposite angles are congruent. Okay, congruent. And that means they are equal in measure. So if you want to say equal in measure in a quick way, you say they're congruent. One word. Yes, they're the same, but in geometry we say that they're congruent. So it's a geometry word that you should know. Congruent, very important word. So then we have angles at a point. So let's just take a point, and you can draw. There doesn't have to be a straight line. Just if we draw out a few rays in any particular direction, you can draw as many of them as you like. Like, think of them as spokes of a wheel, but that not all the spokes are there. Okay, but they don't have to go at a particular distance or anything. They're just all heading outwards. So, and I'll just throw in another one there as well, just for a bit of variety. And we can work our way around here, calling them A, B, C, D, and E. and these 5 angles are all angles about a point. Okay, there's a point there, so A plus B plus C plus D plus E equals 360 degrees. Okay, and the English we used, or the language we use, is angles at a point. So consider that each angle was brought into the point there. Okay, I could even add another one there, but I'm not going to, because then I'd have to break up the B. Okay, so it's a very, very long revision video, and it's even split into 2 by accident, because I clicked the stop by accident. So we're going on to angles and parallel lines. So when we have 2 parallel lines, and we take another line that intersects both of them, so any other line that isn't parallel, and we call that line there I'm going to say it there somewhere, doesn't say it. It's not transducer, it's not transpose, that's a thing from algebra. Transversal. Now, I haven't been using that word regularly enough, recently enough, so I was stretched. It wasn't in my long-term memory. Okay, so I know now, I'm learning from that mistake that I delayed getting that word, that I need to work on this word. I need to make sure I can spell it and I can say it, and I know that this line is a transversal. Okay, now let's do some geometry. Let's apply what we've been talking about. So let's say that we have the line A, so AB, CD, EF. So first of all, we can talk about the line AB is parallel to CD. Okay, we can say that EF, the line EF, is a transversal of AB and CD. They wouldn't even have to be parallel for that, but more about that when we do theorems. But it's a transversal, it transverses across them. Okay, so once we have a transversal, we can talk about corresponding angles. So this angle, now I've used capital letters here, and they're going to use small letters here. So angle F, or let me just use extra letters. So X and Y are corresponding angles. So corresponding angles are equal. So A equals B. You can find them by looking for an F shape. Well, sort of an F shape at a stretch. Now they've done the internal corresponding angles, but that's fine as well. Okay, so let's just do this again. So the thing about productive maths is you can, and exploratory maths is we can redraw as often as we want. Okay, so if I draw this here like this, and let's say I just don't continue it on that way. This is where they're talking about the F shape. So let me mark in my F in straight edge. So there's an F. And these angles are corresponding, like it says in your book there. A and B are corresponding. Okay, now we're going to go to alternate angles. Which looks like a Z. So when you trace out this bit here, it looks like a Z, and this angle here, they're using A and B again. A and B, in this case angle A is equal to, you can use 3 lines because they're congruent, but is equal to angle B always, because they're what are they? They're angles. And what makes them alternate is they're at alternative sides of a transversal. Okay, so the word transversal comes back into it there. Transversal. So the meaning of alternate is they're at either side of a transversal and they're both internal. Okay, now these would also be internal and they would be alternate angles and they'd be equal to each other too. Okay, and then we have these interior angles, but these are supplementary angles. So let's revise this. So we have like so, two parallel lines, and it's important just to make sure that you don't come up. That's almost a right angle, so it's a bit misleading. Okay. So these two angles. Well, first of all, you see this one here? It's the same as this one here. So, so if I call this y like they did in your book, and then I'll call this y dash, but they're equal. And we'll call this x. So x and y dash is the same as x and y, and they add to 180 because they're a straight angle. Okay, so x plus y equals 180 degrees, which means they supplement each other, because if you've already got x and you add on y, you add on, and adding on is supplementing. Supplementary angles always add to 180. They don't have to be adjacent, they're not here, but they are supplementary. So interior angles, yes, they add to 180, that's the maths bit. But we also say interior angles are a pair of interior angles, and they're a pair. This is a different pair here, say A and B are a different pair. Interior angles are supplementary. Great. And then we have exercises. I'll do them, and then we'll have started off section chapter 8, and then the rest of the sections will probably be a lot quicker. So describe in words each of the following. So it's, first of all, this is not words, but what I'm looking at there is this, and this is called line segment AB. The next thing is so part 2. I know the Roman numerals, so we really have to get used to them in text and text. So 2, what we say there is just, we write AB, but we say the line AB, that's all. Okay, the next thing is the ray BA. Okay, but what they should have asked us to do is also describe in maths and in words, because this is a picture. Okay, so I'm going to go through that again from the left. I'm going to say the maths way of saying it is line segment AB, and you just heard me say it. You won't write it often, okay, because when you write that, it is pronounced line segment AB. Okay, the part 2 is the line AB, and part 3, and line AB is written just like this, and part 3 we have to start at B, so part 3 is ray BA, and also just written ray BA. Great. Go on to question 2. So 63 degrees in A form a straight angle. Okay, so A equals 180 degrees minus 63 degrees equals 117 degrees. Okay, 6 away from 7 is 1, 3 away from 10 is 7. Okay, I'm just going to spread them out the way correspondingly to how they are here. Okay, now we're going to start using our calculators. So for B, I'm going to do 180. Now I will write down, always write down what you put in your calculator. So 180 minus 67 minus 28 equals, and into the calculator that goes equals 85 degrees. The next bit Well now, okay, you could do 180 minus 45 minus 90, but what you might notice is that C and 45 degrees are, now we call that not supplementary, we call it they complete each other, they're complementary. Okay, which means C is equal to 90 minus 45, which is equal to 45 degrees. Okay, now I don't know that I give you a word around a point, but the word is conjugate angles. Conjugate angles are the angles about a point. If we went back along with our notes to here, these are conjugate angles. Now the maths bit is more important, they all add up to 360 degrees, but at least we have a word for them. Okay, so in this one here, they're conjugate, so the maths we're going to write down is conjugate angles, so the maths we're going to write down is 360 minus 150 minus 70 in your calculator. I'll put this up here where you can see it clearly with the light. So 360 minus 150 minus 70 equals 140. Okay, and another thing we're going to do as we work through every section in the book is we are going to just give ourselves the confidence that we're getting things right by just maybe spot checking, or like I pretty promise you that I won't be making too many mistakes, but it's just nice to be able to check, and I know you like that. So we're going question 8.1 part 2, and I've just got a 140 degrees for D. Great. Dave, oh yeah, it was called D. Silly me. Okay, I can start using the letters that it's named. So maybe that's an improvement here that I looked at that. Okay, so in the next case, again, the word is they're angles about a point. Fancy name for that is conjugate angles, and but I think we will say angles at a point, because you can't forget that, because it spells it out for you, tells you where they are. They're about a point. So angles at a point. E completes the angles at a point, so we're going to do 360 minus 70 minus 80 minus 140. When I put that in my calculator, I get 70. E equals 70 degrees. F equals 360 minus 84 minus 145 minus 108. You put that in your calculator, you get F equals 23 degrees. Will we check? Let's check. 360 minus 84 minus 145 minus 108. Yes, 23 degrees. Okay, work out the angles marked with the letters. So we're going on to question 3, page 167. Okay. Ooh, so there's some problem solving going on. So when you look at a problem like this, okay, let me just reconstruct it here. We have A, B, and 70 degrees. Okay, so each one can be got directly, but we need to work out A and B. So the first thing I'm going to do is I'm going to say A is the easiest one because they're vertically opposite. Okay, so A is equal to 70 degrees. And then we're going to say B forms a straight angle with 70. So we just do 180 minus 70. So B equals 110. Okay, same thing in the next one. So I just say D equals 30 degrees. And actually C equals 150 degrees. We didn't have to do any calculation because we had the two vertically opposites. And I'll just call this one out. E is 140 and F is 40 because it's supplementary, it makes up 180. Okay, we're going on to question 4. In each of the following diagrams, write down the number of the angles that correspond to the shaded angle. Okay, so what corresponds to the shaded angle? So it's going to be 4. Angle 4. Question 4, angle 4. Okay. What corresponds? 7. And what corresponds? 4. So it went 4, 7, 4. Excellent. Okay, what corresponds? 4. I'll write down the size. I can make this a little bit bigger for you to read on YouTube by flicking it over. And let's click. Do I click in the middle just to make it full size? So write down, you see all that, you can. Write down the size of the angles marked with letters in each of the following diagrams. So basically A is alternate, so it's 110. And B is supplementary to 110. So B, little b, equals 180 minus 110 equals 70 degrees. Okay, we'll keep this on the side here. Question 5, 110 and 70. And on to C, and I'm just going to call these out because there's very little calculation. C is alternate, so it's 46, and D is supplementary, so it's 134. Take away 46 from 180, 134. There's a 120 here, so F is 120 because they correspond, and E is 60 because so I'd say they're angles about a straight line or supplementary. I'll favor saying angles about a straight line because that's the vocabulary you're going to get in your textbook, and I don't want to confuse you. That can't have that. Okay, so question 6, find the measure of the angle marked with the letters. So we start off with P, it's 80. From there, now we have these two parallel lines, so we got to kind of identify that, and there's a lot of other stuff going on, so we have to be careful. So this is what our first of our angle chasing tasks, angle chasing. And also it's just a bit of problem solving where we carefully get to know, to look at what we know. So this line that I'm tracing down along here is a transversal of the parallel lines. So Q is the same as P. So let me write out P equals 80. Q, and I'll say Y, vertically opposite. Q is also equal to 80, and I'll say Y, alternate to P. S equals 80 because it's vertically opposite to one we know to be 80. 75 is forms a straight angle with S. No, this is 80. Oh, this isn't 80. Silly me. Look at that. So this, wow, that's a lovely question. I'm going to have to draw this in order to give you the answer. I'm going to take my two parallel lines, and I'm just going to, so it's not to scale, so no one's going to get out of, there's no point in getting out a protractor and telling me that this isn't exactly 80. That's not important. Okay, and I'm going to bring this line down here. Now notice I just did it by hand, but that's okay. So I have S here, I have 75 degrees here, I have Q here, and when you draw by hand it's called sketching. As opposed to plotting. Plotting is using equipment and measurement. So sketching is by hand. And we need to know both skills. So here we go. I'm continuing on here with 80 degrees here, and I'll just say P equals 80 degrees, Q equals 80 degrees. This is 100 degrees. This is 100 degrees. Or 75, because it's corresponding to that. So that took me a while. Okay, so I have or equals 75 degrees. So you saw me persevering and keeping going. Or is 75. Now we know these two, and the three angles here have to add up. S will be 180 take 75. That's all the letters. I've named them all now, so it took me quite a while. It was difficult for me, but I persevered. So we get S is 105 because it is a straight angle here, and OR was, what did I say OR was? OR corresponded. So when we see this, it corresponded here, so it was 75. OR was 75. Question 6, OR was 75. Okay. So these are very difficult, challenging questions. As you can see, I'm struggling to finish them myself. Very long video, but only one to go now. No, two to go. So we'll. And what you're seeing too is that it's very hard to do them when you're looking at the book. So what I'm going to do is I'm going to draw it out and do it here. So it's the and it's only by doing this, instead of just giving you homework and expecting you to be able to do it and me never doing it, you're seeing that I'm in the trenches with you. And it allows me maybe to give you a little bit richer teaching, or at least to reflect on how challenging it is for you and what's important. So I've got my two parallel lines and I've got a transversal. Now instead of completing the diagram, it might be no harm. Here's a good strategy. Let's start solving it with what we have so far. Okay, so we've named this E and this is 1, 1, 2. So straight away they want me to get E, so E equals 180 minus 112 because their angle is about a straight angle, and that will go into the calculator and it'll come out at 68. Okay, so this is a better way, a nice way to do it. Another thing we can do here is we can fill in, you know, that is 68 as well, just as we go, because it might be nice to know that. Okay. And let's come down to F and G. So F corresponds with 112. G corresponds with 68. Let's put circles around everything we've calculated. Okay, now we can continue on our diagram. Continue on our diagram. We have a 96 here, so B is 96 because it corresponds to that. And so this A equals 96 because they're vertically opposite. And C is complementary, so it's 84. Not complementary, supplementary. Again, this is a straight angle, so this is 84. So I filled in C, B, A. I filled them all in. That was question 7. All done. Aren't these great fun? Okay, and now we're bringing a bit of algebra into it as well here. Okay, so we're going to start 8 part 1 with reconstructing it. And we know that this is 120 degrees, so this is 120 degrees. But we know that that there is 4n plus 60. So we'll turn this into a linear equation. We'll turn it into an equation which happens to be linear. 4n plus 60 equals 120. So all our algebra skills have to kick in now. So we'll transpose the 120 term across and get 4n equals 120 minus 60. 4n equals 60. And now we'll divide down the 4 factor. So n equals 60 over 4, n equals 15. Great. Two more parallel lines, an extended one and less of one, and we just start here and come up with a transversal. It verses, it verse. What does verse mean? So verse, it moves across. So it's a transverse. Remember, I'm trying to learn that word off so that you're going to hear me say it quite a bit, so that I can embed it into my long-term memory. There's 68 degrees. So 3n plus 25 is an expression for this angle. These are add to 180. They're supplementary. Now they're not they don't form a straight angle, but mathematically it's the same thing. So what I'm going to do is say 3n plus 25 is equal to 180 minus 68, which is 112. So 3n plus 25 equals 112. Transpose across the constant term, and we get 3n equals 112, take 25. Bring your calculator in there so that you don't get too tired with all the mental maths work. So we have 112 minus 25 equals 87, and 3 will divide into that. 3n equals 87. Divide down the 3 factor. Well, we don't have to show it, but we will show it. Of course we'll show it. And it will divide it in. Well, it would have gone into 90 30 times, so the answer is 29. Okay, so I did a nice little mental maths trick here. I kind of partitioned 1987 into a difference of 2 multiples of 3 that were more friendly to us. Okay, and then we can distribute in the 3, giving us 30 take away 1 equals 29. That's n. Let's test. That's a really tricky one to test. 29. Oh, I have one more to go, and I thought I was finished. But I did get 29 degrees here. Aren't we great? Except I forgot the degrees. 1 to go. And that was one heck of a homework. So do we have parallel lines here? We do. And we have 2 kind of separate transversals. So this looks interesting because they don't seem to tell us anything. But they do tell us something, because we can write down, first of all, we need to analyze this situation and say, what's the relationship between that and this? Oh, this is a really cool problem. 5n minus 10. So these two here, this one here, even though I don't need it, I'm chasing this angle, I'm using it temporarily, okay, is the same as that. So that means I can write 3n plus 38 here as well. Okay, so here's your angle chasing and problem solving at its best. So now these two angles are supplementary, they add to 180, don't they? Yeah, because they form 2 adjacent angles in a parallelogram. So what we're going to do is we're going to add them together. Now if we add them across the page, it'll look like this. I don't need to introduce a bracket when I'm adding a binomial, so I'm not going to introduce a bracket. But I would also say it's much easier to stack them the way we do with addition in primary school, so we can certainly do it this way as well. Either way, you get 8n plus 28. And we know that that's equal to 180 degrees. Okay, so we get 8n equals 180 degrees minus 28 degrees. We get 8n equals 152. We get n, divide, so I've transposed to 28, I've divided down the 8 factor, 152 over 8. Let's put that in. It's 19, and n equals 19 degrees. No, is it degrees? Yeah, because there's no, if we look back here, there's no degree sign on it, so n has to be 18 degrees. Let's see, did the book... Oh, 19. I read that wrong. That's 19 degrees. I can't see my calculator. Oh, I wrote 19 as well. So n equals 19 degrees, and n equals 19 degrees. Sorry, I'm not sure that I said the word 18 there a second ago, but of course I calculated it to be 19, and it is 19. Now that's the end of one section. And I suppose just to say, it's only when you do all the questions you realize how much work is involved. And I hope you learned an awful lot. These videos are there to help you learn independently, so you don't have to get it all done in class. And I hope you are working alongside me, understanding the solutions as we go. As always, students, I will see you in the next one.